So far in this unit, we have discussed congruent triangles. And what we learned about congruent triangles is two things. First, there's a series of rigid motion transformations that map one triangle directly on top of the other. But second is this idea here that we have congruent triangles. There are a total of 6 congruent corresponding parts. That is 3 angle congruent statements and 3 side congruent statements. The good news is, if I'm asking you to prove that 2 triangles are congruent, we do not need all 6. You don't need to go through a series of 6 congruent statements. We're really only going to need 3 of them, but it can't be just any 3. There are certain criteria that have to be met. So what today we're going to learn is, what are those criteria? Before we go any further, there's a few definitions we need to learn or be reminded of. First is something that's new, and it's called the included side or the included angle. Included side is the side that touches both angles. So what is the included side of angle A here and angle C up here? Well, there's 3 sides. There's side AC, there's side CB, and there's side AB. The only one that touches both angle A and angle C is AC. So we would consider segment AC as the included side of angle A and angle C. So an included side has to have 2 reference angles. Similarly, when I'm asking about the included angle is formed by the 2 sides referenced. What that means, if I'm referencing side PA, this side here, and side NP, this side here, those 2 sides form an angle. In this case, it's angle P. Angle P becomes my included angle because it has been formed by those 2 sides. The idea of included angles and included sides is going to play a very important role in proving triangles congruent. So let's make sure we understand that concept. The next one is the reflexive property. This is one that we discussed last week. Reflexive property states that, and I can mark that segment here congruent, and if I labeled my triangles here, triangle ABC, and probably shouldn't use C twice, so we'll go back and we will use D. We would state that segment AC is congruent to segment AC. So it states that any segment is congruent to itself. Any angle is congruent to itself. That's the reflexive property. So the first 2 congruence postulates is what these are called, that allow us to prove triangles are congruent. The first one is called side angle side congruence. It states that if 2 sides and the included angle, so the included angle means the angle formed by your 2 sides of one triangle, are congruent to 2 sides and the included angle of another triangle, then your 2 triangles are congruent. Look at it this way. If I call that point A, that point B, that point C, and I call this point G, E, and O. If I know that segment AB is congruent to segment GE, segment AB congruent to segment GE, I know that angle A is congruent to angle G. And I know that segment AC is congruent to segment GO. Those 3 things allow me together to make a conclusion. That conclusion is this third side, there's only one possible length for it, which gives me two triangles. That allows me to conclude that those triangles are congruent. So now when I'm naming my triangles here, the first one I can name anything I want. I'll name it triangle ABC. It is congruent to triangle. Now my second one must match up with my corresponding parts. I know angle A is congruent to angle G, so I have to list angle G first. A goes to B, that's segment AB, so I need segment GE, so I have G, I have to go to E, and then O. This is an example of side angle side congruence, because I have been given congruent side, another congruent side, and the angle that those two sides form. When I'm deciding if it's side angle side congruence, I'm really only looking at one triangle. The second idea here is called side 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 congruence, SSS. So I'll write it up here. That's called side 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 congruence. This one was side angle side congruence. Side 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 is just simply stating that the three sides of one triangle are congruent to the three sides of another. So if, again, I have triangle ABC and I have this time, let's call it triangle RS and T. If I know that AB is congruent to RS, or segment AB is congruent to segment RS, I know that segment BC is congruent to segment ST, and I know that segment AC is congruent to segment RT. Those three things together are sides. That's a side, that's a side, that's a side. Those are my three congruence marks. That means that together, knowing that, I know that triangle ABC is congruent to AB has my one tick mark, RS has my one tick mark. So I have to name it triangle RS. I went from A to B to C, so BC is my two tick marks, ST is my two tick marks, so RS, T, that works by side 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 congruence. The most important thing to keep in mind here is when I am writing my proofs later on, I'm going to be using this format down here. I'm going to need to have three congruence statements here before I could ever say my triangles are congruent. These three congruent statements are either going to be segments, like this one, or angles, like this one. And then I'm going to be able to conclude my triangles are congruent. On our next video, we're going to learn about two more of our possible triangle congruence statements.